Hello fellow engineers. So today I'll be showing you the rule that guides my column placement. I believe once you learn this rule, you would be excellent when carrying out general arrangement. It's a simple rule. It's all about knowing what works in construction. So first thing to do when you get the floor plan and you want to carry out a general arrangement, you make a copy of the floor plan. Then you go ahead and delete all the architectural features on the plan. So once you've removed all the architectural features, the next thing you need to do is overlay the first floor plan on the ground floor plan. That's basically overlaying the perimeter of the first floor plan on the ground floor plan, in order to know if there's a cantilever or a recess on the project. So you do that by tracing the perimeter of the first floor. So once you've done that, the next thing to do is to copy the perimeter and place it on the ground floor. You need to pick it from a common point, which is usually around the staircase area, and place it. Then you can offset to 30 millimeters. So you can see there really isn't a cantilever on this design, except if you want to interpret this balcony as a cantilever. Apart from that, there really is no cantilever on the design. So the next thing we do is we begin to place our columns. The rule guiding my column placement is this: if I want my beams to be of 450 millimeter depth, which is what I use most of the time for residential projects, then I know that I can span my columns 5.5 meters apart. Okay, so once I pick out the column, I would model a rectangle which would symbolize a panel for me of 5.5 meters. Okay, so this now shows that if I want to make my beam of 450 millimeters deep, the next column I should place should be around here. But you can see this lands in a window, so I can either place it at the edge of the window, or it looks better here on the main grid, on the structural grid of the design. So I would copy this and place it over here. Okay, so you can see some people might place a column here, here, and here, but really you only need 2 columns to handle this panel. You don't have to place columns so close to one another. You can go, if you know what you're doing, you can go as wide as you want to. Emphasis on if you know what you're doing. Okay, so we'll copy this and place it. So we'll copy this and place it over here. You can see that it's still less than 5.5 meters. Okay, so the next thing we do, we could copy this one, place it on the edge here, and we move our 5.5 meter panel over here. We place it on this side. You can see it works here, and so the next column we need to place should be somewhere around here. Well, it's now falling in a window, so we'll look for a place that is suitable, which is over here, and then we'll copy the column and we'll place another one over here. So you see it falls within our region of 5.5 meters. So then I can move this rectangle over here. So 5.5 meters from this side would give me here, but this falls in between a lobby. Okay, it falls right into the lobby, so it's best I place the column over here. So I can do the same on the other side, because this is 5.5 meters, so the column placement would work. So next thing I do is to move the panel guide I'm working with and place the next columns. So you can see we can have another column over here, but then if we have one here and have one here, it may be too close. So let's look for a more suitable position for it. So if I copy this, I already know I would definitely have one at the edge. So once I place that one at the edge, and I would most likely have another one at this edge, and I move my 5.5 meter panel, it shows that I need to have yet another one over here. So then I can copy this and place at this point. Okay, if you want to go ahead and place another column here, you can see that it's not necessary. You have a perfect distance between these two columns of 5.5 meters, and it's even less than 5.5 meters, so it would definitely work with 450 mm deep beam. Okay, so then you move your panel to the next column. So we would copy this column, this panel, place it on this column, or more or less remove it, sorry. So it shows that we need to have another column within this area, because from here to here, the distance between these two columns I've already placed is greater than 5.5 meters, so it's 8.775. So I need another column to break the span. So it would be wise to have one that just continues with this structural grid and gets all the way to here. So you can clearly see that we're already bringing out our panels, our beam layout, and our slab layout. We're not done with the column placement. We still need to place columns around this part of the building. So I'll move this 5.5 meter panel and place it over here. You see that it falls in the window, so I need to move the column over here. So copy and you place it over here. Similar thing with this guy, you copy and you place it over here. Make sure that they're in line, so you have a very good structural grid running on that side. So now you've put them in line, and they're also in line with this other two. So you move the panel guide, place it over here. You can see that you can place a column here, but it's already outside of the perimeter of the building, so you just go ahead and place it right at the edge. We could actually decide to place one here also. So we could have the shape of the building, which is this corner shape over here, or we could decide to move this guy over here. But if we do that, we know that we've gone against our rule of 5.5 meters, so we would need to really pay close attention to this beam because it might fail. So if you want to be too safe, or if you want to be safe, you could place another one here. But safe doesn't mean But another option is you could also take this guy out, model, run your analysis, and see what happens with this beam. If it fails deflection, then you just need to increase the depth of this particular beam to about 600, and you know that every other beam on the project would be 450. They're just different ways to go about things. This is not one rule. Civil engineering is a very versatile industry. You can do a lot of things. My design and your design do not have to be exactly the same, but we should all follow the basic principles of design, which says that the design of the structure should be stable, durable, and economical. Emphasis on economical.